Hi, in this demo we'll focus on breast cancer from the TCGA program. TCGA is well known for its comprehensive genomic profiling of many cancer types. What's less familiar is that at the start of the CPTAC program, researchers took subsets of TCGA samples, including breast, ovarian, and colon cancers, and performed deep proteomic profiling. This gives us a perfect opportunity to explore proteogenomic data in one integrated view using BioInsight. Here on the login screen, we can sign in either with a BioInsight specific account or via Google. For this demo, we'll log in with Google. First, let's explore proteomic data from PDC. I'll start by asking, is there proteomic data available for the TCGA breast cancer cohort? The chatbot confirms that proteomic data exists, giving us the bridge between TCGA's genomic information and CPTAC proteomics. Next, we look at key breast cancer genes: TP53, PIK3CA, YARBB2, and BRCA1. We generate a heat map across the TCGA-BRCA proteomic cohort. This shows expression patterns across patients, helping us quickly identify differences in protein levels. We can focus further on YARBB2, plotting protein expression for HER2-positive versus HER2-negative patients. This confirms expected biology. HER2-positive patients show higher YARBB2 protein levels, consistent with clinical classifications. Finally, we can identify specific patient subsets. For example, which patients show low TP53 protein levels. The chatbot may ask for additional clarification if there's not enough information available. Here I will choose bottom 25%. The chatbot lists their IDs, ready for further integration or analysis. Now let's integrate protein data with genomic information from GDC. We ask for mutation status of TP53, PIK3CA, and YARBB2 in TCGA-BRCA, and match these to the PDC cohort. This helps us see whether protein levels align with mutation status. For example, certain TP53 mutations may cause protein accumulation, while others reduce it. Next, we compare protein and gene expression side by side. We pull TP53, PIK3CA, YARBB2, and BRCA1 protein expression from PDC and gene expression from GDC for the same patients, and display them in a box plot. This highlights cases where RNA and protein expression don't perfectly correlate, which is common in cancer biology. We can also explore outcomes. We can ask the chatbot can generate Kaplan-Meier or survival curves stratified by PIK3CA mutation status to investigate survival differences. Finally, we can compare YARBB2 protein levels between patients with or without YARBB2 amplification or mutation. This integrated view helps us understand subtype-specific biology and potential therapeutic targets. Next, we expand to clinical trials and drug response. We ask, are there breast cancer datasets with proteomic data from patients treated with paclitaxel? At times, the chatbot may return errors. Simply rerun the prompt or rephrase with additional information. The chatbot identifies datasets such as CLGB40601 neoadjuvant trial studies. We can then compare YARBB2 protein abundance between TCGA-BRCA samples and paclitaxel-treated cohorts. This helps us see if HER2 signaling differs between untreated and treated populations. We can also query for metabolomics datasets for paclitaxel-treated breast cancer patients, and even request more information about paclitaxel, including visualizing its 3D structure. Lastly, we can search for pathology and radiology data for the TCGA breast cohort that has both genomic and proteomic information. To summarize, we can ask the chatbot to list all the questions we've asked so far, giving us a convenient overview of the analysis steps. Finally, we summarize what we learned from integrating PDC, GDC, IDC data for TCGA-BRCA, and correlate with other breast cancer studies from clinical trials cohorts. In summary, this demo illustrates how BioInsight enables conversational exploration across multiple cancer omics resources, from discovering studies and identifying key genes, to exploring their mutations, correlating gene and protein expression, and linking across data commons for deeper multi-omic insights. It offers an intuitive, integrated way to help researchers unlock the full value of public cancer data.